Hello friends, hope all you are fine and doing well. Welcome to our channel SRHVAC. In today's video, we are going to see how to read the VRV system drawing or how to read the basic VRV drawing, where we will take up the complex engineering concept into simple, easy to follow lesson. In this video, we are going to learn how to read the VRV drawing. We will walk you through the piping layout, indoor units, outdoor units, wiring, and we will see also the VRV schematic diagram of the VRV system for a hotel. So friends, those who have not subscribed our channel, please subscribe so you never miss an industrial insight, tips and tutorials. So friends, let's start our today's topic, how to read the VRV drawing or how to read the VRV system drawing. First, before starting this one, we should know what is VRV. VRV stands for Variable Refrigerant Volume. It is a type of HVAC system that uses the refrigerant as a flow for cooling and heating medium. It is similar to VRF flow and often terms are used for interchangeable depending on the brand. The VRV is being patented by the Daikin company. The rest of all using the VRF brand. Friend, in a typical VRV system, there are mainly four components. There will be a indoor unit, there will be a refrigerant pipe, and we have a wire joint which connects the pipe and the wiring and connection system between the each indoor and the outdoor unit. These are the four main components of a VRV system. So friend, let's start our today's topic, how to read the VRV drawing. When we receive a drawing from a consultant or an owner or an architect, we should first read what are the main legend it has, because all the main components are given in the HV legend. So you can see number 1 is supply air duct. Okay, this is denoted with this symbol. You have a 4-way cassette unit. You can see the 4-way cassette unit of Daikin. This is the 1-way cassette unit of Daikin. Okay, this is the 4-way. This is the 1-way. Then this is the concealed clean unit. Okay, this is the ductable unit. This is the symbol for our VRV pipe. One is our gas pipe and another one is our liquid pipe. Okay. The next one is our drain pipe. They are denoted by this. Okay. Then if we have a supply air diffuser, you can see it is crossed. Okay. This is a single line. This is the return air diffuser. The next one is fan coil unit. The next one is supply and return air. This is denoted by this symbol. Okay. And next one is fresh air duct with gap. Okay, this is denoted by this. We have the next one is Y connection. You can say Y joint. The Y joints, one is for liquid, another one is gas. And the next last one is VRV outdoor unit. This is denoted by this one. Okay, you can see the drawing, the terrace one. This is the outdoor unit. Okay, so I hope you understand VRV how important it is. Okay, first here you have to check what are the items given in the legend of it. Okay, the other thing are typical how the pipe will be connected and the supporting angle. Okay, and this is how the anchor fastener is being put and grounded. Okay, the other one is next one is Y branch, how supported it will be 1 to 1.5 meter. And you can see that this is the Y branch or Y joint. Letting detail. We are using the ducting. We are not much into this one. Okay. Now we will start from the top terrace level where the outdoor unit is situated. So you can see here the first one is 38 HP, one is 20 HP, another is 18 HP. Outdoor unit. Okay. The dimension is sharp. Okay, one system is 38, another one is 34, 18 plus 60. Okay, so the other one is 36, 18 plus 8. Okay, this 2. So means total there are 6 outdoor units. Okay, and there are 3 systems, 38, 34 and 36. Okay, this is all in the terrace floor. I hope you are clear what are the outdoor units. Okay, now we go to the third floor of this hotel. Okay, we start now. You can see ceiling suspended unit of 20 are 1700 into 5 is 300. From where you will get the dimension of this one. Okay, we will go to the catalog for Daikin. Okay, you can see this is the ceiling suspended unit. Okay, so there is 2 TR. 2 TR means 63. The capacity is 60. You can see FXMQ 63 PVE. You will see in the third floor. The schematic. You can see this is the FXMQ 63 PVE 2 TR. The capacity index will be 62.5. The piping will be 15.9 and 9.5. Okay, similar. So from where we get this 15.9 and 9.5? Let's check it. We will go to the pipe chart of the Daikin that is being supplied. You can see the indoor unit capacity index, piping size. Okay, so 0.563 means to do 15.9 and 9.5. You can see from the catalog also. From here also you can see this. You can see 9.5 and 15.9 is the pipe size. How much CFM it is? It's 8. And BTU is 24,200. If you divide by 12,000, you will get the TR 7.5. If you divide by 3.51, you will get the TR. This is detailed from the Daikin catalog. Okay, we have seen both. We have seen from the catalog as well as the pipe sizing chart for 2 TR 3.9, 9.5. Okay, I hope you clear up to this one. Okay, this is the 2 FCU. Okay, we have FCU connected to the canvas. There is a small thing. There is a supply grid. Okay, you can see the supply grid is 14 into 1. Okay, this is a 6-inch grid. There will be a return air grid. This is the return air. Okay, the drain will be going to this shower. Okay, the drain pipe. Okay, this is the first layout for this one. Okay, for these 2 rooms. Then next you will get the Y joint 125. How will you get 125? It is 62.2 and 62.2. This total is 125. Okay, and T is 20T. You will see how 20T. You can see below 200 capacity index is 125. So we are getting 22T. Okay, from this chart you will get 22T. So you get a 22T. There is a 125 capacity index adding both the unit. Okay, and the pipe size is 15.9 and 9.5. From where we get, we will see again the chart. We will see the chart. This is 100 to below 200. Okay, now it is 125. Now it is below 150. So it will be 15.9 and 19.5. So 125 it is 15.9 and 9.5. Similarly, this 125 we have to add, we will get 150. Okay, from where we get this one? This one we will get this FXMQ 50. The capacity index is denote is 50. Okay, and you can see the Q is 19,100. You divide by 12,000. Okay, the air flow and 300. Okay, CFM is 673. Pipe size is 0.4 and 12.7. You can say half. Okay, I hope you understand up to this one. One more piping for this system, it is going from this room. Okay, this is also 1.6. You can see this is 12.7 and 6.4. Okay, the liquid and the gas. This is also 1.6. So the total is 100 CFM capacity index, and the T will be 22T. Okay, just now we have seen the how the T is coming. Okay, the pipe size will be 15.9, 9.5 because it is below 150. The next one is 1.6. So similarly, 150 pipe size also 15.9, 2.5. As you can see. So friends, for this area, particular area in the third floor, this zone you can say the total CI value is 457.5. Okay, we are doing for this circuit. Okay, 38. You can see in the schematic also where is the third floor. This is the third floor. You can see this side. Okay, the total is 487.5. Okay, these are the 1, 2, 3, 4, 5, 6, 7, 8, and machines there. You can recheck with the CI value of each one from this schematic drawing to your shop drawing area. Okay, so this area for the third floor it is clear. Now we move to the second floor. This is your typical name. Okay, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, total 9 machines there. and the similar 487.5. But we have seen in the third one, the similar machines are there. Same 2TR FQ, the drain will come to this area, and we have a supply air fill. There will be a return air. I hope you understand this one. Okay, that's the, then we are going to the first floor, and it is 325, the total one. Okay, how we receive this one total? Okay, by 100, 175 plus 50 is 1.6, going to 225. 225 plus 100 equals 325. The 72 P, somewhere 72 P, that already again. Okay, 72, 290, 640 will be 72 T. So this part. Okay, you can match from the catalog chart. Okay, for for this circuit means there will be a 487. There will be 487. The last floor is 325. We are adding on this one. So friend, I hope you are clear up to this one. Okay, so 325 plus 487 get 1.5 and last is 73 to 30. Okay, for this one we have a 38 HP. We have this one. So I you clear about this zone. So one more thing I have forgot to tell you. This is the looping for wiring for communication between the indoor and the outdoor unit. This is loop. The wire is 1 square mm to okay. This is loop. This is going to outdoor for communication. And for outdoor electric connection, we are using 10 square mm for 18 as well as 20 HP outdoor. So friend, this side is clear. Okay. This section we have seen. Now this will be similar. This section we are taking 36. Okay. This one is going to FCU. Okay. This is the different one-way cassette unit. This is the one-way cassette unit of Daikin. We have seen in the legend also. Okay, one-way cassette. Okay, one more. There are two one-way cassette units. So two cassette units are in this circuit one way. Okay, and rest are all similar unit 1.6, 1.6, same 1400 into 6 inches. Okay, 150 mm supply grill. The return there will be 1.6. The last one is okay. So we check here. Okay, this is the our one-way in this. So friend, I hope you are clear about the piping and indoor unit, how to read the piping, as well as indoor unit, how to calculate the CI value, okay, and how to find the branch, okay. For this one, this is the similar. So we have seen this unit, and this unit. I hope this is unit. So in the restaurant, they have how much? 2 TR into 6 unit, cassette unit. They have cassette. Okay. This is the 3 by 3, 950 by 950 cassette. They have 2 TR. From where we find in the catalog. So friend, this is the catalog. This is the catalog for Daikin. Okay. We are using 2 TR, AFX63. Okay. This. Okay. This is the 2 TR. These are all the damage. Piping is 9.5. Okay. This is 15 and 15. This is the panel. Okay. This is the catalog for this is the unit that is you can see 15.9, 9.5 for the 2. Okay. Y joint here they are connected. Okay. Here also we are using one way cassette. Okay, and there is in this party hall we are using 3.3. So we see the spec this one also. This is the 100. Okay, which we kilowatt to divide this we get the TR and 115 with the ER. Okay friends, the piping used 10.9 and 9.5. Two cassette also. So means they are using 3.32, 1, 2, 3, 4. Okay, and one of each 2x2 and 1, 2, 3, 4, 5, 6. 6 units of 2 TR. We also see in the schematic. You can see there are 2, 3, 4, 5, 6. Okay, and the other circuit is this is 100 3.3 TR. This is 1, 2, 3. We are getting 1, 2, 3. We calculate all the CI. You get this. Okay. And this is going 16 plus 18. Okay, the diversity is. And this is the piping as well as outdoor unit. This is the indoor units that are being used in the VRV system. In the ground floor they are using do not use they are using the HVAC. They are using 4 8.5 unit of ductable. You can see 1, 2, 3, 4. Okay, and the CFN is 3. There is no connection of VR. So we are taking this one. So friends, this is all about our VRV system drawing. How to read the VRV system drawing or VRV drawing. Hope you like my video. If you like, please subscribe, comments. There are a lot more content coming up on your way. See you in the next one.